So in this video we're going to take a look at a PHET simulation of firing a projectile straight into the air. There's a couple things to remember. One is that as soon as this projectile leaves the cannon, the only force acting on it is the force due to gravity. Okay, we are neglecting air resistance. If the only force acting on it is the force due to gravity, that means the force is pointed towards the earth, so straight down. And it means that the acceleration of this object is going to be the acceleration due to gravity, which is 9.81 meters per second squared down. I think we all know that when a projectile fires up, it has to come back down. So let's just take a look at what's going to happen here. So I will choose the person. We'll fire them directly up. Initial speed of 18 meters per second. Mass of 70 kilograms. Okay? Over and over and over again, we can see the same thing is happening. So now I'm going to change the initial speed. You will notice that they simply do not reach as high of a height, and that they are not in the air for as long. One thing I'd like to mention here is that when we reach our maximum height, we have to stop and we have to go in the other direction, right? So when we reach the maximum height, we have to come to a stop. If we come to a stop, that means our velocity is going to be 0 meters per second. The reason I put this little y down here as a subscript is because it is our velocity in the y direction. If this guy were moving in the x direction as well, things would be different, but we'll address that in another video. Okay? Again, it's very important to note that at all times our acceleration is down. That's why I put this negative. And it is 9.81 meters per second squared. At all times. It doesn't matter where this guy is. At the very top, when he's first fired, as he's falling back down, even when he's moving up, his acceleration is down at 9.81 meters per second squared, because the only force on him is the force due to gravity. Okay, so the next thing I'm going to do is I'm going to put the initial speed at 18 meters per second. Our mass is 70 kilograms. We fire. We reach some maximum height. It looked like it was about 16.4 meters. And I'm going to change his mass. You'll notice the maximum height didn't change, even though the mass was much higher. Now the mass is much smaller. Again, the maximum height does not change. So the mass of the object does not matter, because no matter what the mass of the object is, the acceleration is negative 9.81 meters per second squared. So the time this object is in the air, the height it reaches, is all independent of mass. This is because it is free fall. The only force is the force due to gravity. Now, if we want, we can break the motion of this object up into two halves. Okay, so if we look at the total flight of the object, first it has to go up, and then it has to come down. So those are the two halves we can break it up into. It turns out that when we first fire this object, it has some initial velocity. We've already discussed that at the very top, the velocity is 0 at maximum height. But then it falls back down. Because the acceleration is constant the entire time, it turns out that the speed when it's fired is going to equal the speed when it returns to its initial position. The velocities, however, are different because one is up and the other is down. So in this case, our initial speed was 18 meters per second. So our final speed, or rather our final velocity, is negative 18 meters per second. Our initial velocity we called positive, so it went up. Our final velocity right here, when it returned to its initial position, is negative, because we called negative down. Now the time of flight, we can break down into the time to the top and the time to the bottom. And it turns out again that they must be equal. So the time to the top is 1/2 the total time of flight. So looking right here, it looks like our total time of flight was 3 seconds. Because at all times the acceleration is the same, it's going to be symmetrical, meaning that the time up is going to be exactly the same as the time down. That means in this case the time up would have been 1.5 seconds, so it took 1.5 seconds to reach maximum height, and then it took 1.5 seconds to fall back to where it started. So again, we've got 1.5 seconds up, 1.5 seconds down, for a total time of flight of 3 seconds.